In this video, I'd like to talk about a special product of polynomials, specifically known as a difference of squares. So a difference of squares comes up when we have a product of two binomials, let's say a minus b, where a and b could be any type of term, and we multiply this by a plus b. So it's the same numbers, a and b, in both of these two binomials. It's just in one we're subtracting and one we're adding. Now, to actually multiply these out, remember with multiplying binomials that we just use distribution. So this a term will multiply to both of the terms in the second binomial, and this minus b will multiply by both terms in the second binomial. So we get a times a, which is a squared. We get a times b, which we can write as just plus ab. We get minus b times a, which I'll write as minus ab since we can switch the order. And then we get minus b times b, which is minus b squared. And when multiplying out this special product here, notice that the middle terms here are going to cancel out. So this positive AB will cancel with this minus AB. So plus AB minus AB, that's just 0. And we get a squared minus b squared. So notice that we have subtraction and we have two different squares. And remember that the word we use for subtraction, we call that a difference. And we have two different squares here. So the a is a square and b is squared. So we have a difference of two squares. So that's where the phrase comes from. And there are two different approaches we can take to this problem. The first approach is that we can actually just use this formula. We can notice what a is, and we can notice what b is, and then just plug them into our formula. Since we know if we're taking a plus b and multiplying it by a minus b, doesn't matter which one is first, then these multiply together to give us a squared minus b squared. So just applying that formula, a squared minus b squared, we would get 4b squared squared, and then we subtract 3 squared since b is 3. And we simplify. So 4b squared, we could really just write it twice, 4b squared. And since we're squaring it, we get 4b squared again. And then 3 squared, we know it's just 9. Now multiplying monomials here, we can multiply the numbers. So 4 times 4 is 16. B squared times b squared is b to the 4th. Since they have the same base, so we can just add the exponents. Or you can just think it through. We have two b's multiplied together, since this is really just b times b. And then we have two more b's here, and so in total we have 4 b's multiplied together. So our final answer should be 16b to the 4th minus 9. Now, we can also check our work by using another method. So the other method is essentially what we did here to get the formula. And we're just going to take our two binomials, the 4b squared plus 3, and multiply them. So we get 4b squared minus 3. And when we multiply, we just use distribution. So we do 4b squared multiplied into both of these terms. And then we do 3 multiplied into both of these terms. So when we multiply the 4b squared to both, we would get 4b squared times 4b squared, which we know is 16b to the 4th. And then 4b squared times minus 3 would be minus 12b squared. And then we do the 3, we multiply that into both of these. So 3 times 4b squared, that is plus 12b squared. And then plus 3 minus 3, that's just minus 9. Now, fully simplifying this, we would get 16b to the 4th minus 9. Since notice that the two middle terms here are going to cancel out, just like they did when we did it very generally. So minus 12b squared plus 12b squared, that's just 0, so those go away. And we get this 16b to the fourth minus 9, which is the same answer we got when we used the formula. So for really any problem, it's a good idea to check your work if you can, especially if you need to know for sure if the answer is right or wrong. So if you're taking a test, for instance, that would be a good opportunity to use both methods here.